Then I'm going to show you the trick, and then we're going to use the trick for the first problem, and then we'll actually get into what we're doing today. Does that make sense? Okay, this one. What form is this equation in? Intercept form, okay. Intercept form deals with P's and Q's. What's P? 1. We switched the sign, so it comes from right here. What's Q? 5. It comes from this piece. What about A? A? -2. It's always the number out front. -2.
Do we need A?
For intercept form, no. For our trick today, yes. So that's why I pointed it out. Okay. From our P's and Q's, what information do we automatically know? We don't have to do any work for it.
The X's are 7.
The intercepts. That's why it's called intercept form. So our x-intercepts are 1, 0, and 5, 0. To find our vertex, that's when we have to do a little bit of work. We have to have this formula memorized to get the x-coordinate. What's the formula?
P plus Q divided by Q.
Perfect. If you don't have that memorized, you will be not good on the test. You won't be able to graph it, and it won't be good. You have to have it memorized. Same with all of the vertex ones. So the one we talked about today, the HK, and the P plus Q over 2. You just have to memorize them, or else you will not be able to graph it, period. Okay. P plus Q, 1 plus 5 over 6. 1 plus 5 over 2. 6 over 2. 3. Okay. I have the x-coordinate of my vertex. It is 3. In general, how do I find its corresponding y-coordinate?
Put it into the table.
Plug it in. Make a table, plug it in. That's going to be the trend always. For any of these graphing ones, I want you to find the vertex first and then immediately plug it in. So here's 3. I'm putting it in the middle of my table because I know I'm going to have stuff both ways. Okay. I plug in 3. Let's just do it in our head. 3 minus 1. 2. 3 minus 5.
-2.
2 times -2. -4 times -2. Positive 8. Okay. If you want to show the work of actually plugging that in, that is so fine. But you get positive 8. Okay. Now, I know a few other things. I know I have a 1, 0 point. I'm just going to fill these in. 1, 0, and 5, 0. So let me just also get the other 2. 2 and 4. And remember, this 3, 8 here is my vertex. That's what I'm reflecting over. How would I find out, how would I get the y-coordinate for 2?
Plug it in.
Plug it in. Okay. 2 minus 1?
1.
1. So this essentially, it does nothing. It times 1 is just itself. So I'm going to ignore that. 2 minus 5?
-3.
-3 times -2. 6. And if 2, 6 is a point, what else is a point?
4, 6.
4, 6. Now I'm going to graph it. My vertex at 3, 8, that's up here. 2, 6 would put me right here. 4, 6. 1, 0. 5, 0. There's one more point that I don't necessarily need for my graph because I have 5 points here. That's fine. But I need it for my y-intercept. What should I plug in for x to find my y-intercept?
0.
0. Okay, I plug in 0. 0 minus 1 is -1. Times -2 is +2. 0 minus 5 is -5. -5 times +2 gets me -10. Perfect. -10. Again, if you need to just put that straight into the calculator, that's fine. If you want to do it in your head, that's fine. But the biggest mistake I've seen all day is people plugging numbers in wrong. So take your time, make sure you're using parentheses, make sure you're keeping your negative. That is the biggest mistake I've seen all day. Okay? So just make sure you're double checking that all of those points make sense. Okay, there's my graph. I can fill out the rest of my vertex. It's at 3, 8. What's my axis of symmetry? X equals 3. It matches the x coordinate of my vertex. Be aware, if you don't write this as a vertical line, if you just put 3 and you forget the x equals, I'm going to count off. I probably won't give you any credit. Okay? It has to be a vertical line. So you have to write x equals 3. Y-intercepts. What's my y-intercept? We just found it. 0, -10. Which direction does my graph open? Up or down? Down. That came from our -2 as our a value. If it opens down, is my vertex a maximum or a minimum? Maximum. It's the highest point. That value is 8. It gets as high as 8. Domain is always all real numbers. -infinity to infinity. Don't miss that on the test. That's like free points. All real numbers. Range, starting down here, do I have points at -infinity? When do my points stop? 8. 8 included or excluded? Included. So we put a bracket.
Yesterday on the homework in your answer key, you had like the table and then you skipped some numbers and you just, I think you had like 6.
I was counting by 2.
When do we know that we have to go?
You don't. I know because I know number theory and I didn't want to deal with fractions, so I avoided them.
Okay.
You don't worry about it.
Those were really-
They got gross with fractions, right? Just deal with the fractions. It will take me longer to explain the theory behind the numbers than actually doing the fractions.
Can you explain how you got -10 again?
Yes, I plugged in 0.
Oh.
Up here. I got -10.
Okay.
Is that enough of an explanation? Okay. One thing I'm forgetting on my graph. What am I forgetting? Yeah, my axis of symmetry. Draw that in.
Do we ever expect it?
Yes. And I promise you will forget because I forget all the time. So draw it in. Just draw it when you draw your vertex. Questions on this one? Okay. From now on, the only time you ever have to plug in a point is if it's the vertex. Everything else, we're not going to plug in anymore. I'm going to show you a trick. Here's the trick. You will like it, I promise. Here's the trick. It all depends on what number A is. If A is 1, let's observe some things about these graphs here. If I start at my vertex, how many units up do I have to go to get to my next point? Okay, I went up what? Whoa. I went up 1. What about from this point to this point? Up 3, okay. What about that point to the next point? Up 5, okay. Same thing on the other side, up 1, up 3, so on. We can change our graph. This still goes up 1, up 3, up 5. Even though it's a different graph. A is 1, we still have 1, 3, 5. Down here, we still have up 1, up 3, up 5. And we still have it over here. So here's the trick. What you do is I still want you to at least start by still writing out your table. You're just not going to plug the points in. So here's our table XY. And let's just say we have a vertex at 0, 0. I'm just giving you an example. Here's our vertex 0, 0. What you need to do is on the left column for your x's, you always have to count by 1. Notice we're only moving 1 to the right every time or 1 to the left every time. So we're always counting by 1. So down 1, up 1, up 1. The left side, you should just be able to count it like it's on like a number line. It should go in order, should count by 1. The right side, you count by 1, 3, 5, 7. So we count by 1, going both directions. So what's 0 plus 1? 1. And then we count by 3. 1 plus 3. 4. Be aware, we're not adding that 3 to the vertex. Thanks, Ian. We're adding it to the point that I just got. So we're not restarting at the vertex. We're adding it to my new point that I just got. My next one would be 3. What number? We add 5 next. Yeah, plus 5. So 9. Perfect. Okay? We didn't have to plug anything in besides to get the vertex. Okay? Musab.
We still have to put the table up though, right?
For now, yes. After today, I will start to say, okay, plot your vertex and just go over 1, up 3. Over 1, up 5. Over 1, up 7. Okay? But for now, I still want you to show it because you'll still be messing up. I promise.
So is it 3, 5, 7?
1, 3, 5, 7. Has to start with 1. Okay, so that's when A is 1. We have 1, 3, 5, 7. If A is anything else, the trick still works. We just have to multiply our 1, 3, 5, 7 by A. 1, 3, 5, 7 by A. So here, A is 2. So instead of 1, 3, 5, 7, we would count by 2, 6, 10, and 14. Okay? We can check that with our graph here. We went up 2, we went up 6. If we had another point, it would go up 10.
Wouldn't it be 2, 6, 10, 14?
2, 6, 10, 14.
Oh, that looks
I
like
thought
a
it was
2.
20.
Oh,
Yeah.
sorry. Sorry. 10. There you go. I was like, it is 2, 6, 10. So it works for 2. It works for fractions too. If A was 1/2, it would be 1/2, 3 halves, 5 halves, 7 halves, which gets really gross, but you can still do it. And it works for negatives. Instead of adding these numbers, we would subtract them. So if A is like -2, we would subtract 2, subtract 6, subtract 10, subtract 14. Natalie.
We're just doing the same, but it's 2, 6, 10.
Yes. This is still your 1, 3, 5 rule. It still works the exact same way. It's just not 1, 3, 5. It's 2, 6, 10. Perfect. Was that your question as well, Ava?
No. When we make a table, then we, on the left side, we added 1, we added 3, we added 5, then we got the solution. Do we have to multiply the solution by the number like A? Or this
A is only
2, 6,
used,
10, 20?
yeah, A is only used to figure out what numbers you're adding to your y coordinate right here.
So I use 2, 6, 10, and 14, and then adding.
Yes. So let's do an example. Let's go back to our warm up here and let's do this example without plugging in any points and just using 1, 3, 5, 7. Okay, well, maybe not in this case. First of all, this is from yesterday or from Tuesday. What form is this in? Vertex form. So it should immediately give me my vertex. That means I need my A, my H, and K. What's A?
2.
2. What's H? 1. We flip the sign. What's K? 3. We keep the sign. Okay. Again, this is just one of those things you have to memorize. The x coordinate of my vertex is what? It's HK. So 1, 3. If you don't have that memorized, you have nowhere to start. You'll be stuck. And that's not something I can help you with. So you'll just be stuck. Or the junior office. You know where it is. You're gonna go. Oh goodness. Up. You're gonna go out.
English hallway.
Left. English hallway. Beautiful. English hallway. English hallway on that side. Okay. Go up the stairs.
It's like right by the
Go
stairs.
across the bridge. And then across that hallway.
It has
to the
a
next hallway
sign.
over.
Look for the
They're right
sign.
by the stairs.
There'll be signs, yeah. If you start looking confused, someone will help you. Okay. I didn't want to call him out while he was here. He's a new student in our class. He came from a different school. Welcome him with loving, open, kindness arms. Thanks. Yeah, you might know him. He went to Parkway Central, so. Mustafa. Okay. Back to this. We have our vertex. Again, if you can't find your vertex because you don't have this stuff memorized and you ask me on the test, I'm going to say, tough luck, I can't help you. That's not something I can teach you. That's just something you have to memorize. Okay? So here's our vertex. Let's fill out some other things that we know. What's my axis of symmetry? X equals 1. Perfect. Comes from right here. My x-intercepts I don't quite know yet. Y-intercepts I'll find from my table. Which direction does this open, up or down? Up, because A is positive, which means it has a minimum. What's my minimum value? 3. Comes from right here.
Can you just write 3 like times?
Yeah. Like that's as low as my graph goes, 3. If it said what's
It's
the...
not like in a point.
No. If it said minimum point, you would say 1, 3. But this is really like the minimum occurs at 3 when x is 1. Is like really what that means. Domain is always all real numbers. We can do the range. It's going to open up, so it's going to look like this. I have nothing down here. When do I start? 3. It doesn't look like it on my graph, but my vertex is going to be at 3. So I start at 3. Included, and I'm good to infinity. Okay, that is all stuff we could have done yesterday. Here's the new stuff. On the left, again, you have to count by ones. If you don't count by ones, it will be all sorts of screwed up. So we're going to count down by 1, so 0, -1, and we're going to count up by 1, 2, 3. Now we look at our 1, 3, 5, 7 rule. A was not 1, it was 2. So I have to take all these numbers and I multiply them by 2. 2, 6, 10, 14. And they're positive, so I'm adding. So I start at my y-coordinate of 3, and I add 2 to go both directions. I get 5. Then I start at my y-coordinate of 5. I'm done with the 2. I add 6 in both directions. I get 11. And that's all my graph can fit. Even 11 falls off a little bit. So I'm going to graph. -1, 11 is just slightly above my graph. Close enough. 0, 5, 1, 3, 2, 5, 3, 11. Draw a curve. Don't forget your axis of symmetry. And you're done with the graph. Questions on going from just vertex and A to this entire table, this entire graph. Because that's what you got to know how to do. Go ahead.
What would the x-intercept be?
We're going to talk about it. Does this look like it crosses the x-axis ever? No, we have none. And in general, if your graph opens up and your y-coordinate of your vertex is positive, that means it's already above the x-axis and it's going to keep going up. So you're never going to touch the x-axis. Same thing if it's going down and you're already below the x-axis, you're never going to cross it. You're just going to keep going down. So no intercepts happen quite often. May.
So is like not putting the line of symmetry something that we would lose points over?
Yes. Probably. I will say yes for now.
What about drawing the arrows?
I need arrows. Some teachers are not sticklers about it. I am. You need arrows. It's a line.
So we'd like lose points if we didn't.
You'll lose half a point for every problem you don't have an arrow on.
Okay.
And if you do it more than twice, I only take off 1 point total. Does that make sense? Okay. So you're not like triple penalized. Okay. So no x-intercepts. What about my y-intercept?
0, 1.
Perfect. That came straight from my table, 0, 5. What if it didn't come from my table? Plug in 0 and figure out what it is. Perfect. You might have to do that. One of the problems in your homework or on the stations, your y-intercept is like at 30 something. So it's not going to come from your table because we're not going to count that far. So you'll just have to plug in 0 to find it. Questions on anything from the first page? Do we like 1, 3, 5, 7? I hope we do. It'll save you time. Natalie.
What is less than 1?
You just make it negative. Like a fraction. You just still multiply that fraction by your numbers. So 1/2 times 1 is 1/2. 1/2 times 3 is 3 halves. 1/2 times 5 is 5 halves.
So A was 3, would it be 30?
9,
Oh.
15, 21.
So you just times it by
You
whatever.
just multiply A by all of these numbers. Exactly. Positive, negative, fraction, doesn't matter.
I thought it was just
No, all of them. We've just done a lot of 2s. Any other questions? Okay. Our very last form that you will have to know how to graph. Again, on your test, there's going to be one of each of those 3 forms, so you have to know all of them. You have to memorize at least the vertex portion of all 3 of those. Okay? Here's the new form, standard form. This is not new. Everything we factored was in standard form. So we have our ABC, that's not new, and our exponents decrease by 1. Okay. This is the part that you need to memorize. X equals negative b over 2a. That is how you find your x coordinate of your vertex. Okay? So that is step 1. This is the first thing you should do always. From there, use your table, use your 1, 3, 5, 7, and do it all how we've been doing it. Okay? So in general, now that we have that 1, 3, 5, 7 rule, kind of the steps that I've been giving you are a little bit too detailed. For all of them now, step 1, find your vertex. Step 2, find 1, 3, 5, 7 stuff and be done. 2 steps. Vertex, find the x coordinate, plug back in to find y, and then do your 1, 3, 5, 7. Okay? So, everything else is the same. So, A still changes how narrow or wide our graph is. So the bigger A is, or the farther away it is from 0, the narrower our graph is. The smaller A is, or the closer it is to 0, the wider our graph is. If A is positive, it opens up. If A is negative, it opens down. And there's one more thing that the standard form immediately gives us, and that's our y-intercept. Okay? If we plugged in 0, this first term's going to go away. The second term's going to go away, and we're just going to get C. So you can totally memorize this if you want to. Completely not required, because plugging in 0 to this equation takes basically no time. Okay, so you can memorize it, but that's something you could also just get really fast by plugging in 0. So up to you. Questions on just what standard form is, what we need to memorize. Again, this is what you need to know. Negative b over 2a. So, we're going to kind of walk through our steps as we do this first example.
Is there no x-intercept?
You'll just have to find it from your table. Yeah, there's not an easy way to find it. So, vertex form, you can find the vertex easily. Intercept form, you find the x-intercepts easily. Standard form, you find the y-intercept easily and have to work for everything else. It's not super user-friendly, but we're going to do it anyways. So, step 1. Identify all your coefficients. What's A? -2. We're quiet today. A is -2. What's B? What's C? -6. What is the one formula I need for standard form? Perfect. Negative b over 2a. So, -8 over 2 times -2. -8 over -4, +2. That's all. Everything else is the same thing as we've been doing. I fill in my blanks. My vertex is at 2 something. My axis of symmetry is x equals 2. Again, those should always match. And I use a table to find the rest. So, here's my table. Here's my vertex. For standard form, I would recommend either using a calculator and just being careful. Remember, if we square a negative, we have to put the negative in parentheses. So -2 squared is +4. So either use a calculator or do what I'm about to do and kind of take it step by step. So if we plug in -2, +2. +2, so you won't have to put parentheses around it. But if we plug in +2 to our function, -2 times 2 squared plus 8 times 2 minus 6. You can totally just plug this straight into the calculator. I've seen many people today plug it in incorrectly, and they could not get the right number because our calculator skills are struggling a little bit. So Do whatever you want to do, but I would just pick the safest option. Pick what you're confident in. Okay. 2 squared is 4 times negative 2. Negative 8. 8 times 2. 16 minus 6. So this is kind of what I mean by taking it piece by piece. And now, negative 8 plus 16 is positive 8 minus 6 is positive 2. So my vertex is at 2, 2. Everything else is my 1, 3, 5, 7 rule. So on the left, I always have to count by ones. So I go to 1, 0, and 3, 4. I'm just counting by ones. 0, 1, 2, 3, 4. Okay. On the right, I use my 1, 3, 5, 7. So 1, 3, 5, 7, but A is negative 2. So I multiply all those numbers by negative 2. Negative 2, negative 6, negative 10, negative 14. I like to write them down just so I don't lose track of where I am in the 1, 3, 5, 7. So, what's 2 minus 2? 0. Remember, it's negative, so we're subtracting now. 0. Same thing down here. 0. Now we need 0 minus 6. Negative 6. And we're done. We graph it, and we're finished. So, 2, 2 right here. 1, 0. 3, 0. 4, negative 6, 0, negative 6. Draw your axis of symmetry, and then you are good. Question? Yeah, go ahead.
Wait, isn't it negative 4, not 0?
2 minus 2?
Oh, minus. Oh, I thought we were multiplying.
No.
Oh, okay.
We're adding and subtracting. So this isn't times negative 2, it's plus negative 2. Great question, because someone else asked that a different hour. Any other questions? Okay, let's go to the next one. We'll do this one together, and then I'll leave you on your own to do the next one. Also, just something else for standard form. If your x-intercepts are decimals, meaning they don't come straight from your table, I just want you to write decimal. We'll figure out how to solve for them next week or the week after. Right now, we don't know how. So just write decimal.
Instead of the x-intercept.
Yes, like next x-intercept, just put decimal. Don't put none, because it will cross the x-axis at some point. But just put decimal or not pretty number or whatever you want to put. So, here, what form are we in? Standard. So I need A, B, and C. Again, don't try to mix up your forms. If you're given something like this, you're not looking for H and K. You're only looking for A, B, and C. Okay? What's A? 1. What's B? What's C? 3. Then I need the only formula I need to memorize for standard form. Negative B over 2A. So negative 6, positive 6, over 2 times A, so times 1. We get 3. Okay. Now what? Plug it in. Exactly. We cannot do anything until we have the entire vertex. So we plug it in. This one we got in our head, I think. 3 squared is 9. 6 minus 3, or 6 times 3. 18. 9 minus 18. Negative 9 plus 3. Very good. Negative 6. Okay. I'm going to fill out as much of this stuff as I can before I do my table. What's my axis of symmetry? X equals 3. Vertical line going through my vertex. Again, you have to have the x equals part. X-intercepts I'll deal with later. Y-intercept, the one formula that you don't really have to memorize, 0, 3. C is 3. That would have also just come from our table if we just waited a second, so no problem there. A is 1, so does it open up or down? It's positive 1, yeah, up, which means I have a minimum of -6. It's your Y.
How'd you guys find out -6?
We plugged it in. Plugged 3 into our equation. We got -6.
Okay, and then the Y-intercept?
0, C. C is 3. So 0, 3. Okay?
0 times 3.
No, the point. 0, C. 0, 3. The ordered pair,
So
0,
you can
3.
only do that standard form.
Yes. Okay. We can actually do domain and range too. Domain is always all real numbers or -infinity to infinity. Range, this thing's going to open up. So it's going to start at the vertex. So at what Y value? -6 included. So with a bracket. And it's going to keep going all the way through to infinity. Okay, table time. A is 1. So I don't need to do anything special. I just have 1, 3, 5, 7 that I'm adding each time. In the X column, what do I need to count by? 1. It is always 1. If you do something else besides 1, your entire graph will be messed up. So I'm going to count down by 1 and up by 1. Okay. Now I'm looking at my 1, 3, 5, 7 rule. -6 plus 1. -5. So I'm done with the 1. -5 plus 3. -2. So I'm done with the 3. -2 plus 5. 3. I could keep going, but I don't need to. Questions on the table? Okay, let's graph it and then we're done. 3 -6 puts me right here. Just kidding. Puts me right here.
Why'd you go farther than the 5 points?
Just because I wanted something positive. I wanted to know if my x-intercepts were going to be decimals or not. So I had to go from negative to positive because it had to cross. So I see where it crosses. You don't have to, but it might confuse you for this part. So 3 -6, 2 -5, 4 -5, -2, and 3. Draw your your axis of symmetry. And then we're done. So like Musa was saying, he was like, why did I have to do more than 5 points? Technically you don't, because I said 5 points are required and that's it. But I wanted to double check to make sure that my x-intercepts are going to be decimals. If I never made it from a negative to a positive, my graph, like I would have drawn it, but I wouldn't have known for sure that it's a decimal. It could have ended up landing on a whole number. But here, my x-intercepts are between those 2 points. So here between 1 and 2, or between 0 and 1, and between 5 and 6. So they're decimals. We just write decimal. And we save it for later. Questions? Okay, I want you to do number 3 on your own or with the people around you. Check with me when you're done, because I'll be drawing random people out of my sticks. This one over there. That's good. That's okay. That's just your vertex. That just means your vertex is over here. A. A is positive. No, this is good. This is right. Mine's graph.
I have another question. I'm really confused on the x and y.
Okay, x-intercepts is when y is equal to 0. So it's something 0. So you're looking in your table when this happens. If it's not in your table, you write decimal or none.
No, never this is the x.
I'm doing this
X.
is
Mhm.
So it would be this point and that point, right?
What?
Why are you
These
playing
2
this
points.
Yeah, and those are not going to be nice pretty numbers. And you could tell if you just kept going one more, you would have went to a positive number here and a positive number here.
Yeah, it does.
So
You
it's
have
some-
some higher editors
Yes.
to edit it and whatever.
Wait, but it's like touching the line.
Well, yeah, that's what an x-intercept is when it touches the line. Oh, that's just because you're,
I said negative 6 divided by 2 is equal to
where did these points come from? Looks like you grabbed negative 1, 0.
You just grabbed this.
Makes sense.
Oh, yeah, these are not points. You just drew your parabola a little too steep. It's supposed to like kind of come down like that.
Okay.
Like that.
So if it's like, if there's a point on one, you have to.
If there's a point that is from your table on that line, that's when you put it.
Okay.
If not, it's gonna be a decimal or it's not gonna happen at all.
Okay, same thing for y.
Y, you will always have Y, so just plug in 0. You will always have one.
Wait, where do I
Is 0, you plug 0 into your.
He's been like.
So Y intercept is when X is equal to
I
0.
see.
Okay?
Can you control them?
Nice, because most journalism editors.
Huh? Perfect.
Yeah. More about numbers than I think I've learned.
Yeah.
A year.
It must be an issue like
Just be careful, your vertex, your Y, or your X coordinate should be -3. Start there. Yes, that's good. Should be -3. Should be -3 and then plug it in. How'd you get
X intercept or decimal?
No, it is negative b equals 2a. Okay. Okay, so try
You
to.
get the width. It'd just be this.
You need your vertex?
No, why does it need to have that many points?
I got you.
What?
On the table? Why does it need to have that many points?
What table? Hold on, which one?
Value is.
This one?
Yeah.
I just added an extra point because I wanted to get to 0 so I could fill out this information.
Oh, okay.
That's all.
If we go, sorry.
Yes.
Is it,
Oh, I know. Perfect.
Wait, no, wait, that's.
Yes, good.
Yeah, you.
Give you about 1 or 2 more minutes. Mhm.
no. Wait.
I like to do 7, yeah. Caliper.
Is it
You
negative
multiply
2?
it by first of all, and then you just.
You feel that. Oh.
First of all, you multiply it with 3.
Oh, we multiplied by 3.
Yeah, like 1 times 7, multiply them by.
It's less than 1. Oh, it's 0 positive. Would 0 be a positive? Sorry, this is bad. Like if we're doing like this.
Yes, it's good. Oh, that one?
Yeah.
It should be negative.
Negative?
Well, you plug in 0, what are you gonna get?
It's negative b divided by 2a, right?
0's right, that's how you got 0, it's negative b over 2a. But once you plug in 0 back into here to get y.
Oh.
Oh, yeah.
To my y, yeah, but 0 for x is perfect.
Okay, yeah.
Great. All right, let's do this one, number 3, together. If you do, well, first, A is 1, B is 6, C is 2. If you do negative B over 2A, you get negative 3. And if you plug that negative 3 in, you get negative 7. If you struggled to get negative 7, we gotta focus on our calculator skills, okay? Because on your test, it's gonna screw you up if you keep plugging things in and getting the wrong thing back. It will screw you up every time. So just be careful when you go straight to your calculator. So XY for our table. Here's my vertex. A is 1, so I'm just counting by normal, or 1, 3, 5, 7, and I'm counting by 1s on the left. Just be aware, if I'm going from negative 3 and I'm going down 1, I'm counting by 1s like backwards. I'm at negative 4. -5, -6.
It's okay if I like.
If you switch them, like put these ones down here, that's fine. I would just be careful. Just pay attention. And then if we add 1, -2, -1, 0. Again, I'm kind of going to 0 here because I know I need a y-intercept. Now I use my 1, 3, 5, 7 rule. Brayden, what'd you get for the y-coordinate for -4? If we're using 1, 3, 5, 7. Bless you.
Negative. Oh, yeah, I got -4.
-4, what's your y?
I don't know. I didn't do the table for that one.
That's okay, but okay, what's -7 plus 1? If we're doing 1, 3, 5, 7.
-6.
Perfect, -6. Careful, watch your negatives, but good. -6. Now we need -6 plus 3. Natalie. -3. And then last one plus 5. -3 plus 5 is 2. Okay, we're done with the hard stuff. We just got to fill out the rest. Axis of symmetry, x equals -3. Those always have to match. X-intercepts. Right here, I switched between positive and negative. So I have 1 point right here and 1 point right here. And my x-intercept is somewhere in between.
Decimal.
It's a decimal. Yeah, it's somewhere between -5 and -6. I'm not sure where. I write decimal. Next week we'll see that most of these are irrational numbers with square roots in them. So, what about my y-intercept? 0, 2. It opens up because A is positive, which means it has a minimum value. Oliver or Peter, what is that minimum value?
Value is -7.
Not -6.
That's 7.
Oh, yeah, -7. Sorry. Perfect. -7. Domain is always all real numbers. Range, we open up. So I'm going to start at my vertex, which is at -7 to infinity. Last thing, just have to quickly graph this here. Here's 0, 2, -1, -3, -6. That is what your parabola should look like. Brayden.
Is it always going to be like a decimal for the x-intercept unless a point lands on like the line?
Yeah. So unless literally from your table, unless one of these numbers is 0, and then no, it's always going to be a decimal. Yeah. Sometimes it will come out to 0. It just happens that way. But typically, I think a lot of the ones in your homework come out nicely, but in the notes it just all worked out as decimals. Any other questions? Okay, let's do this one, and then we only have 2 more. We're almost done. What's weird about this function? There's no b value. We're missing our middle term. Let's add one in. Let's put a placeholder in. Plus 0x, so I can get my b value. So now, it's in standard form. A is 3, b is 0, c is -9. This one's going to be pretty quick. -b over 2a for my vertex. -0 divided by anything is just 0. So no matter what we even divide by, this is going to be 0. Do I really have to plug that 0 back in? No, because I know for a fact that 0c is a point. What's c? -9. Now I'm just going to fill out some other things I know. My axis of symmetry is the y-axis, x equals 0. Not sure about my x-intercepts yet. My y-intercept is 0, -9, same as my vertex. So right here. A is +3, so does it open up or down? up. Yes, Yara.
For like the vertex, where'd you get the -9?
I just know that if I plugged in 0, you could do two things. One, if you plug in 0, first term just changes to 0, -9, so -9. Or two, if you have this point memorized, you knew that it had to be 0C. Okay? Since my graph opens up, do I have a maximum or a minimum? Minimum at my y value of -9. Domain is always all real numbers. I'm opening up, and it's a minimum, so that's where I start for my range. I start at -9. And I go to infinity. Now I have to do my 1, 3, 5, 7. I'm counting always by ones on my x column. So -1, 2, and 1, 2. Instead of counting by 1, 3, 5, 7, what am I really counting by?
3.
Yeah, 3 and 9, plus 3 plus 9. 1, 3, 5, 7 goes to 3, 9, 15, 21. So, -9 plus 3 is -6. -6 plus 9 is +3. We reflect them over. And then we did all the hard work. We just have to graph it now. So draw your axis of symmetry. -2, 3 is a point. 2, 3 is a point. And then 1, -6. And -1, -6. Questions on that one, Ava?
Why is it not negative, like the 3, 9, 15, 21?
Because our A was +3.
But then we multiplied by the negative x, right? Oh, no. Okay,
Got it? Okay, perfect. Any other questions on that one? Okay, you are going to hate this next one. It gets really ugly. It's fractions. I know, Natalie, I'm sorry. We're going to do everything the exact same way. I am just giving you a fair warning that we're dealing with fractions, and I'm going to show you how to do them all by hand.
Do we have to do fractions or can we do decimals?
Decimals is fine. Yeah, for this one, it's over 5, so that's fine. But if it was like over 3, where it's 0.33333 repeated, don't do decimals.
Okay.
Because it's not right. It's not accurate or precise. Yes. Okay, we're not going to change anything that we do. This is still in standard form. What's A? -3/5. What's B? 2. What's C? 2. My vertex is at -b over 2a. So -2 over 2 times -3/5. The fractions begin. What do you say? What do you say?
Is it 3 over 5?
Very close. I'm going to flip it. I'm going to simplify the 2's first. What's -2 divided by 2? -1, right? So now I have -1 divided by -3/5. When we divide by a fraction, what do? We change our sign to multiplication, and we flip. So I'm keeping the -1, multiplying, and flipping my other fraction. Do you see now? We multiply by the reciprocal. This is totally something you could plug into the calculator. It's also probably totally something you would plug in wrong into the calculator. So be careful, okay? But here we end up getting +5/3 for the x coordinate. Questions on how those fractions worked? Okay, we have to deal with them again because what do I have to do to my 5/3?
Plug it in.
Plug it in. Okay. Negative 3/5 times 5/3 squared plus 2 times 5/3 plus 2. 5/3 squared.
Wait, how'd you get 5/3?
That came from here. I canceled my 2's out, and I just got negative 1 over 3/5. And then I keep change flipped and multiply by the reciprocal to get 5/3. Okay. If I square 5/3, does anyone know what I would get? You square both pieces, so what's 5 squared? 25. What's 3 squared? 9. So you get 25 over 9. Plus 2 times 5/3 is 10/3. Plus, I'm dealing with fractions. Let's write 2 as a fraction. Not 2 over, I have a 3 here. I'm hoping this goes to a 3. How would I write it as something over 3? 6 over 3, yeah. 6 divided by 3 is 2. We just did the hard part. Now it's a little bit easier. Another way to simplify fractions is pick the things that you want to cancel. Here, this is all multiplication. So I can cancel anything I want in any order in this first term. So I'm going to handle the 3 and the 9 because I know something's going to cancel. What's 3 divided by 9? 1 over 3, yeah. So that turns into something over 3. I still have a negative hanging out in front, so negative 1/3. What about 25 divided by 5? 5 over 1. So 5 over 1. So you don't have to deal with super bad fractions with big numbers if you just pick the things you think are going to cancel and make them cancel. So now it's negative 5/3 plus 10/3 plus 6/3. We get negative 5 plus 10 is 5 plus 6? 11. 11/3. 11/3. Whew. That's as much as we're going to deal with the fractions. Because, would we all agree that if I tried to use my 1,357 up here, it's not going to be 1, it's going to be 3/5, and then it's going to be 9/5, and then it's going to be 21/5, and I'm going to keep having to deal with fractions. I don't want to do that. There's another nice, pretty point that I can get from A, B, and C. What's that point? 0C, 0,2. So now I'm just going to put that in my table and see where it is in relation to my vertex. So let's go here. Here's 0,2. 0C. It's a point that's always on my graph. 0C.
You can always do that with
For standard form, yes. Okay. What did I change in my x going this way? How did I get from 5/3 to 0? We subtracted 5/3. So if I want to reflect it, I need to add 5/3 over here. So 5/3 plus 5/3, 10/3, okay? And that's going to have the same y coordinate because I just reflected it. I'll tell you for the other one, I used a calculator, I plugged it in. I'm going to keep going by 5/3 here. So negative 5/3. This would get me 15/3, so 5. If you plug that in, you get another nice, pretty number, negative 3. Trust me, I plugged it in. I used a calculator. Just believe Miss Cruz right now. You will not have to do one this ugly on a test or anything. I just wanted you to see it so you know that these things exist and I'm being nice when I give you nice, pretty ones on the test. Okay. Axis of symmetry, what is it? X equals?
11 over 3.
X equals 5/3. Yeah, it's the x coordinate, okay? Does it open up or down? A was negative 3/5. Opens down. So do I have a max or a min? Max of 11/3. This should be a 3. Domain is always all real numbers. I have a max, so I have really small numbers down here, and I hit a point that I have to stop at. So I have stuff at negative infinity, but I have to stop when I hit 11/3.
you put a And then the negative infinity after?
No, that will be wrong. So for intervals, it always has to be smallest to biggest number, left to right. And then my graph, here's 0, 2, whoops, here's 0, 2. 5/3 is a little bit more than 1. It's 1 2/3. So 1 2/3, and then 11/3 is a little bit over 2. Or sorry, a little bit over 3. We're like right there. 10/3. Oh wait, no. Sorry. 5/3 is a little bit over 1. 11/3 is a little bit over 3. We're right there. Goodness. 10/3 is a little bit over 3. So we have like a little bit over 3, 2. 5, -3. And then -5/3. So -1.6-ish. Harder to graph that one because you're dealing with with fractions that you have to estimate between two numbers. But that's it. Connect your dots, draw your axis of symmetry, and you are done. Questions on that one, Natalie?
Is the x-intercept this one?
Oh, yes, sorry. The x-intercept will be somewhere between these points. In this case, it is a decimal. The only thing you would maybe want to try is -1 here, and I'm telling you right now it's going to get you a decimal. But that's like the only one that you would kind of have to try because it almost looks like it hits it at -1. So we would probably test it. We would test that it gives us a fraction back so we can just write decimal. Any other questions on that one? You're almost done.
Like, and the x-intercepts, if we find that it, like if we graph it and it looks like.
Yeah, so graph it, and it almost looks like it could be -1. Let's see if -1 works. It doesn't, so just write decimal. Because if it's not -1, it's not going to be anything besides a decimal. Ava.
If we forget to put arrows on the axis of symmetry, do we get points?
That'll be like half a point, probably. Crazy. Yes. Any other questions? We're almost done. Let's do one more with fractions. This time the fractions are nicer. Okay. I want to do this one because does this look like all the other ones we've seen? No, what's weird about it?
It's mixed up.
Yeah, it's mixed up. We got to fix the order. 4x squared plus 4x plus 1.
Do you have to rewrite it, or can you just?
You don't have to rewrite it. I just would. You don't have to. But if it's going to confuse you with your A, B, and C, and you're going to say that A is 1, I would rewrite it. Because what is A? 4. Okay, so A is 4, B is 4, C is 1. Just off of C, real quick, what's my y-intercept?
1.
0, 1. Perfect. Okay. I need my vertex. What's my formula?
Negative b 2 times a.
Yeah, -b over 2a. So -4 times 2 times 4 is -4 over 8. Reduce it down, we get
Negative 2.
-1/2. Which again is a fraction, but this is a nice fraction. I consider this a nice clean fraction. It's just 0.5. It's nothing crazy. So let's just roll with it and we'll just keep the decimals on this one. We won't try to avoid them. So here's -1/2. My next step is to plug it in. 1 plus 4 times -1/2 plus 4 times -1/2 squared. Four times -1/2.
Negative 2.
-2. So 1 minus 2. -1/2 squared. Square the top and the bottom. 1 squared is 1. 2 squared is
4.
4. So 1 over 4. 4 times 1 over 4?
1.
1. So we get this. This comes out to 0. Nice and pretty. Which also means, what's my x-intercept? When is y 0?
Oh, 0.
No, when is y 0?
Oh, when x is equals negative 1/2.
Yeah, when x is negative 1/2. So that's also my x-intercept. My axis of symmetry is the vertical line, x equals negative 1/2. And now I'm basically done. I just got to fill out my table. On the left, if I'm using 1, 3, 5, 7, and I want to here, because it'll come out pretty nicely, because A is 4, I still have to count by ones on the left. Be careful. What's negative 1/2 minus 1?
Negative 1/2.
Perfect. Negative 1.5 or negative 3/2. What's negative 1/2 plus 1?
Plus 1/2.
But, perfect. Positive 1/2. Okay. I'm going to leave it like this for now, and you'll see why in a second. But instead of 1, 3, 5, 7, A is 4. So what am I really going to count up by? 4. And then 12, but that's going to fall off my graph. So 0 plus 4 is 4.
Plus 12.
Yeah, and then it would be plus 12, so it would be 16, way off my graph. I'm going to graph it. Negative 1/2, 0 is like right there. Negative 3/2, 4 is right there. 1/2, 4 is right there. This is a really narrow parabola. I know one other point, though. I know 0, 1. I'm going to graph that one just so I can get a little bit better of an idea. And if I graph 0, 1, I can also reflect it and graph negative 1, 1. So this is our graph. Huh?
Why are we going up by ones instead of fours?
I went up by 4 here. This wasn't 1 away. This was only half away, so it didn't count for my 1, 3, 5 rule. This just came from my 0, 1. I just had that point, so I just reflected it without using my rule. Great question.
Wait, so you can't use 1, 3, 5, 7 on that?
Oh, you can. It's just not going to give you the 0, 1. I used 1, 3, 5, 7 to get these 3 points. And then all I did was plot my 0, 1 and reflect it. Just because it wasn't part of my 1, 3, 5, 7, but I still wanted one more point that wasn't fractions.
We plot all of the points like that we found.
Sure. You don't have to. Like if you found 7, you only have to plot 5. But if it helps you, it'll look nicer and it might help you like see x-intercepts and stuff better. So yeah, if you found them, might as well graph them. Any other questions? Okay, clearly this graph opens up. It has a minimum. That minimum value is 0. Comes from right here. Domain is always all real numbers. My range, I start at 0 to infinity. Okay. Questions on that? Okay, one last thing I want to talk about. We're going to talk about it more next week. But no matter what form I give you, it's all the same thing. You're all graphing parabolas. It's going to have a vertex. And in fact, next week we're going to talk about switching between all 3 forms. For example, if I wanted to convert this intercept form, minus 1, plus 3. If I wanted to convert this back into standard form, what would I do? How do I get rid of these parentheses? We would FOIL, yeah, distribute and FOIL. If we FOILed, it would bring us right back here. Same thing here. I would FOIL it, and it would bring me right back here. So you know how to go from intercept and vertex to standard. You FOIL. To go the other way, we'll talk about that next week.
If you forgot something on the test, could you just FOIL?
100%. If you are really good with standard form, and you're like, crap, I don't know how to do intercept form, FOIL it and use standard form. It's all the same thing.
Don't you just factor to go the other way?
We do factor to go the other way, yes, to get this part. So to go from standard to intercept, we factor. To get vertex form, we have to do something else called completing the square, which we'll learn next week or the week after. Okay? But we will learn how to convert between all 3. Really quick, the 3 things you need to memorize without looking at that poster. If I'm in standard form, how do I find the x-coordinate of my vertex? Something over something.
Negative 3 over 2a.
Okay, you need to memorize that. If I'm in intercept form, how do I find the x-coordinate of my vertex? Something plus something over something.
B equals Q over 2.
Perfect. And if I'm in vertex form, it's given to me. What letters is it? HK. Perfect. That's all you need. If you have your vertex, you plug it in, you do your table, you do your 1, 3, 5, 7, and you're done. Okay? Yeah. Questions about any of that? Okay, like I said earlier, your homework's a little bit weird. What I want you to do is I want you to start. I'm going to give you a pack. It's a packet, but it's really only 10 questions. I want you to start on the second page. That's the activity. That's the purple papers. There will not be an answer key posted for that. So I want you to try your best and ask me questions in class. The front page is your actual homework, 3.2. There will be an answer key, but both of these are due Monday for completion grade. Questions, comments, concerns? Okay, I will pass it out. You guys still have about 25 minutes. You should be able to get at least the activity done in that time. Huh?
Is the activity in red?
Yeah. Where's the back?
Is the activity like
Yeah, start in the back.
the very no, the station one?
My grade's so good. Can I go? That's only one.
Yes.
We watched like a movie. It wasn't a movie. It was more about this place who stole $52 million from the government.
So again, all 10 of these for completion. Your homework's out of 10, so if you skip one, you're getting a 9 out of 10.
And was taking money from the farm. And so the town was.
Oh, yeah, I forgot about that. Are we doing absolutely? Yeah, that's fine. Okay, I forgot about that. Perfect. Your eyeliner looks really good. Your eyes are popping. Yeah, thank you for reminding me, because I totally would have forgotten and been confused. We lost that. Perfect.
We can use 135.
100%. A is what? This isn't 135, it's 2, 6.
Oh, this is A.
This is A, yeah.
So I'll just multiply it.
Yes, but yes, 135 works on anything.
Yeah,
I also have